Okay, hello Cloud Gurus and welcome to this section of the course. So this lecture is called DNS 101 and we're going to be looking at Amazon's DNS service, which is called Route53, throughout the rest of this section of the course. Now, first of all, you might be wondering, where did they get the name Route53 from? Well, if you know a little bit about US history, the very first interstate was Route 66. It was the very first road that went from one side of the country to the other. And with DNS is actually on the port 53. So that's where Route 53 gets its name. And that is actually a popular interview question at AWS. So if you are going to try and get a job at AWS as a solutions architect or as a technical account manager, that's where Route 53 comes from. So Route 53 will probably come up 4 or 5 times in your exam. The exam questions are random, so it really depends, which questions you get, but it is definitely a heavily tested topic. And to be honest, if you want to work as a solutions architect in real life, you're going to need to understand DNS back to front. Now in this lab, we are going to go out of free tier because we're going to set up 3 EC2 instances. This section of the course could cost you money if you follow along, or you can just watch me do it myself. So let's start with DNS. What is DNS? And I want you to think of a phone book, and that's the easiest way to remember what DNS is. I know we don't really have phone books anymore, but hopefully you can still remember them, or maybe I'm just getting old. So if you've used the internet, you've used DNS. DNS is used to convert human-friendly domain names, such as a Cloud Guru, into an IP4 or IP6 address, such as HTTP 82.124.53.1. So IP addresses are used by computers to identify each other on a network, and IP addresses come in 2 different forms, IPv4 and IPv6. And this one, the 82.124.53.1, is an IPv4. So that's all DNS is. It's a way of looking up a domain name and getting an IP address. Just like when you used to look into the yellow pages, you'd look up someone's name and you'd get their telephone number. So let's talk about IPv4 versus IPv6. And IP4 addresses have been running out. They've been running out for ages. That's why we invented IPv6. So IPv4 is a 32-bit field which has over 4 billion different addresses. And essentially it has a finite number of addresses. And this worked really well in the early days of the internet because we just didn't have that many devices online. Nowadays, everyone's mobile phone, everyone's computer, everyone's fridge, everyone's Alexa, they all have unique independent IP addresses, and we've just run out of space. And to help you visualize this, I want you to imagine that each IPv4 address is a single grain of sand. If you were to take all the IPv4 addresses and add them up together, they would be enough to fill a dump truck. So that's how many IPv4 addresses there are. We created IPv6 to solve this problem of running out of IPv4 addresses. And IPv6 has an address space of 128 bits. And in theory, this is basically 340 undecillion addresses. So if you then turn this analogy on its head and you take a single grain of sand for 340 undecillion addresses, it's enough to fill up the sun. That's how many IPv6 addresses that there are. Now, a big problem is a lot of ISPs are just not switching over to IPv6. So we're in this sort of weird world right now where we're using both IPv4 and IPv6. But I'm sure that is going to change in the next decade or so. So now that you know what IPv4 is versus IPv6, we're going to talk about top-level domains. And if we look at common domain names such as google.com or bbc.co.uk or acloud.guru, you'll notice a string of characters separated by dots or periods. And the last word in a domain name represents the top-level domain. The second word in a domain name is known as a second-level domain name. And this is optional though, and it depends on the domain name. So we've got .com, that is the top-level domain. .edu is a top-level domain. .gov is a top-level domain. In the UK, we have a lot of .co.uk. So .uk is a top-level domain name, and then the .co is known as the second-level domain name. So that's the difference between a second-level domain name and a top-level domain name. Similarly, in Australia, we've got .com.au. So top-level is .au, and then the .com is the second-level domain name. So these domain names are controlled by the Internet Assigned Numbers Authority, or IANA. And this is in a root zone database, which essentially is a database of all available top-level domains. And you can go and view this database just by visiting iana.org /domains/root/db, and that will give you all the top level domains that are available. Now, because all the names in a given domain have to be unique, there needs to be a way of organizing this all so that all domain names aren't duplicated. And this is where domain registrars come in. And a registrar is an authority that can assign domain names directly under one or more top level domains. And these domains are registered with Internet, which is a service of ICANN. And ICANN basically enforces the uniqueness of domain names across the internet. And each domain name must be registered in a central database known as a WHOIS database. And popular domain registrars include Amazon themselves. It's relatively recent that Amazon have become a domain registrar, but it makes our lives so much easier. When I first started recording the courses, we had to go and buy the domains from GoDaddy and then transfer them over to Amazon. GoDaddy.com is a very famous one. 123reg in the UK is also very famous, etc. So these are places where you can go and buy domain names. Now, when you've bought a domain, every DNS address begins with a start of authority record, or an SOA. And the SOA record stores information about the name of the server that supplied the data for the zone, who the administrator of the zone is, so this could be your system administrator, the current version of the data file, and then the default number of seconds for the time to live file on resource records. And we'll come to what a TTL is in a second. We did kind of cover it off in the Cloud Front lecture. Now, if all this sounds a bit too technical for you, don't worry, it's going to get simpler. So we know what a start of authority record is. It's where our DNS is going to start. We now need to understand what an NS record is. And an NS just stands for name server records. And they're used by top-level domain servers to direct traffic to the content DNS server. And the content DNS server contains the authoritative DNS records. So let's look at an example to make this all make sense. So we've got our user, and they type into their browser, hellocloudgurus2019.com. And their browser doesn't know the IP address for that domain. So what their browser does is it goes to the top level domain server, and essentially it's querying it for the authoritative DNS records. It's saying, hey, I've got this domain called hellocloudgurus2019.com. I need to know the IP address for it. Now, the top level domain doesn't contain the IP address. It's going to contain something similar to this. So it's going to have the the top level domain. It's going to have the top level domain, and then it's basically going to have the name server. So it's going to give it a name server record, and it's going to point to ns.aws-dns.com, and that's the name server record. We then go and query the NS records, and the NS records are going to give us the start of authority. So it's going to give us the start of authority, and inside the start of authority, that's where we're going to have all our DNS records. And our DNS records consist of different things. So we've got our A record, and this is the most fundamental type of DNS record. The A in A record stands for address, and the A record is used by a computer to translate the name of the domain to an IP address. So for example, www.acloud.guru might point to http 123.10.10.80. So that's all an A record is. It's just like the phone example, the phone book example that we were talking about earlier. It's going to take a name and give us an IP address. Now, we have sort of touched on TTLs before. We touched on them in CloudFront. A TTL is basically the length that a DNS record is cached on either the resolving server or on the user's own local PC, and it's equal to the time to live in seconds. So TTL just stands for time to live. And the lower the time to live, the faster there is changes to DNS. And the lower the time to live, the faster changes to DNS records take to propagate through the internet. Now, with most providers, the default time to live is 48 hours. And that can be quite frustrating because if you do make a DNS change, that DNS change can take 48 hours to propagate throughout the entire internet. If someone has just visited your website, they're going to cache that DNS address. So it might be an IPv4 address, and it will be cached for the time to live. And if that's 48 hours, it means if you go in and change that IP address, that could take 48 hours to take effect. And this is my Twitter. Go ahead and follow me. I don't have actually all that many followers compared to how many students I've got. But this is one of my favorite tweets. I tweeted this the 6th of December, and this is a haiku, and it says, "It's not DNS. There's no way it's DNS. it was DNS. And if you're a system administrator, I'm sure you'll find that funny. The reason this is funny is because of the time to live. It can just take 48 hours to do a change, and you're ripping your hair out. You're trying to figure out what the hell is going on, and it's a DNS issue. It's a time to live issue. You have to wait those full 2 days before that change goes in and takes effect. So we've covered off A records. What's a CNAME? Well, a CNAME stands for a canonical name, and it can be used to resolve one domain name to another. For example, you might have a mobile website with the domain name m.acloud.guru, and that's used for when your users browse to a domain name on their mobile devices. You may also want the name mobile.acloud.guru to resolve to the same address, and instead of having two separate IP addresses, you just map one to the other. And if you've been looking at this Yellow Pages one, you can see Batman in here, and then it goes C West Adam. So it does not giving us an IPv4, or it's not giving us a telephone number. Actually, it's just giving us another reference that we can then go up and look, and then that will give us our IPv4 address. So that's all a CNAME is. And alias records are used to map resource records in your hosted zone to elastic load balancers, CloudFront distributions, or S3 buckets that are configured as websites. And alias records are effectively just the same as a CNAME record, and it allows you to map your DNS to another target name. There is a crucial difference, however. A CNAME can't be used for naked domain names. So our naked domain name is sometimes called a zone apex record. Basically, it's the entire domain without a www in front of it, or without a mobile dot, whatever your domain name is, etc., etc. So that's all a naked domain name is. So a CNAME can't be used for naked domain names. You can't have a CNAME for acloud.guru. It has to either be an A record or an alias. And again, we're going to have a look at this in the labs. We're going to go in and set up our very first alias, and that will point to our little EC2 web servers that we're going to provision around the world. And I know sometimes this can sound really complicated, and like I always say, the best way to learn AWS is to get your hands dirty with it. So don't worry if none of this is making sense just yet. It will after we've finished the labs. So onto my exam tips, and I appreciate we have not yet covered elastic load balancers in any detail. The reason for that is we're going to cover it in the high availability section of the course. Elastic load balancers are crucial to understand in order to pass your Certified Solutions Architect Associate exam. You're going to have at least 10 questions on there. But really we need to understand DNS, and we really need to understand VPCs before we can look at elastic load balancers in any kind of detail. So we're going to do those two things first. That being said, what you do need to know going into your exam for Route53 is that elastic load balancers never have a predefined IP4 address. You always resolve to them using a DNS name. So just remember that. You're never going to get an IPv4 address for an elastic load balancer. You really need to understand the difference between an alias record and a CNAME. So just remember, when we're doing our zone apex record or our naked domain name, and we're trying to point that towards an EC2 instance, for example, we're going to be using an alias record. We're not going to be using a CNAME. So if you're in the exam and you're given a choice between an alias record and a CNAME, always choose an alias record. And then just remember some common DNS types. So we've got our start of authority record, we've got our NS record, then we've got our A records, our CNAMEs, our MX records, which are used for mail, and then a PTR record is essentially it's the reverse of an A record. So it's a way of looking up a name against an IP address. So now that we've had a crash course on DNS, what we're going to go ahead and do is we're going to go in and register a domain name, and we're going to start provisioning 3 little EC2 instances around the world as little web servers, and then we're going to be ready to start on the Route 53 section of the course. So if you've got the time, please join me in the next lecture. Thank you.